Okay, so today we're looking at concavity and points of inflection. So our learning intention is to gain the knowledge of using the second derivative to determine the concavity of the original function. And we'll be successful if we can describe and determine the concavity and determine points of inflection. All right, so we're going to really look at the relationship between the first and second derivative. If the second derivative is greater than 0, then that means the first derivative is increasing. If the second derivative is decreasing, it's less than 0, it means the first derivative is decreasing. If the second derivative is stationary, then the first derivative is also stationary. Okay, so if we have the second derivative that's greater than 0, then it means that the curve is concave upwards. If it's less than 0, it's concave downwards. If it obviously equals 0, we need to test the concavity on both sides. We have points of inflection. If the second derivative equals 0 and concavity changes, then it's the point of inflection. Okay. If the second derivative equals 0 and the first derivative equals 0, it then becomes a horizontal point of inflection and concavity changes. Yeah. So they're special. So you got points of inflection where the concavity doesn't change, and then you got points of inflection where you have a horizontal point of inflection when f double dash equals 0, f dash equals 0, and concavity changes. Okay. All right, some examples. We want to find all the values of x for which the function of f of x equals x minus 3 or cube is concave downwards. So the first thing we're going to do is we're going to differentiate that. So the first derivative would be 3 lots of x minus 3 squared. That's the first derivative. And then the second derivative would be that. Okay. And we want to find when it's concave downwards. So we want to actually find, so concave downwards is when the second derivative is less than 0. Okay. So if we're going to do, we've got 6x minus 3, and we want that less than 0. So x minus 3 is less than 0. So x has to be less than 3. Okay. So when x is less than 3, we have the function being concave downwards. Okay. We want to find any points of inflection of this curve. So we're going to differentiate first derivative. And then differentiate that again. Okay. Now, we want to find any points of inflection. So we want to find when the first derivative and the second, so when the first derivative and the second derivative is 0. Okay. So I'm going to factorize things. Sorry, I'm not going to factorize. I will factorize this part because the question is asking us to find any points of inflection. So y double dash will be 6 lots of x minus 1. So if we let the second derivative equal to 0, we get at x equals 1, there is some change of concavity happening. Well, it might be. So when x equals to 1, y equals 3 lots of 1 minus 6. So 3 minus. Sorry, I lied. That's not the function, that's the derivative. I need to use this one. So 1 minus 3 plus 2 plus 9 gives me 9. Okay, so at 1, 9, there is a point of inflection. Okay. Alright. If y equals ax to the power 3 minus 12x squared plus 3x minus 5, and it has a point of inflection at x equals 2, we want to evaluate what a is. So what we need to do here is we need to differentiate it first. So it's going to be 3ax squared minus 24x plus 3. Then differentiate it again. We get 6ax minus 24. Okay, now the question states, so when x equals 2, y double dash equals 0. So and let's solve for a. So we get 24 equals to 12a, so a equals to 2. Okay, good luck.